Our planet holds maps of worlds that no longer exist. We will journey through 25 forgotten landscapes that reveal how Earth took its modern shape. You will discover ancient supercontinents where you could walk from Brazil to South Africa, and vast inland seas that once split North America in two. How did a lush, green savanna become the Sahara Desert? What forces caused an entire continent to vanish beneath the waves? By the end, you will see the ground beneath your feet not as permanent, but as a moment in a story of constant, dramatic change. What does a world that is always transforming tell us about our own future? That unified world of Pangaea could not hold. Deep beneath the crust, immense forces were stirring, destined to shatter that singular continent into the scattered pieces we know today. As the colossal landmass fractured, it did not simply break into our modern continents. Instead, it gave birth to a series of lost worlds, the first of which was a truly bizarre division of the planet. For tens of millions of years, two vast seaways sliced through the heart of the northern hemisphere. One was the Turgei Sea, also known as the West Siberian Sea, a warm, shallow body of water that completely separated Europe from Asia. Where the Ural Mountains stand today as a boundary between continents, a tropical marine paradise thrived. Imagine sailing from the Atlantic Ocean across a sea covering modern-day France and Germany, all the way into a warm Arctic Ocean with no land barrier to block your path. This seaway was a cradle for unique marine life, its warm waters teeming with ammonites and giant marine reptiles, while on its shores, early mammals and dinosaurs roamed completely isolated landmasses. Its existence meant the flora and fauna of Europe evolved entirely separately from those of Asia for an astonishingly long period. The eventual retreat of this sea did not just connect landmasses, it forced a dramatic collision of ecosystems, forever altering the course of life on Earth. But while one sea divided Europe and Asia, an even grander ocean separated the entire world's north from its south. The Tethys Ocean was the defining seaway of the ancient world, a warm, shallow paradise that stretched for thousands of miles between the colossal northern landmass of Laurasia and the southern supercontinent of Gondwana. For over 200 million years, this was the planet's tropical heart, a vast aquatic cradle where life flourished in its warm, sun-drenched waters. Giant marine reptiles glided through the currents, early whales began their evolutionary journey, and the shells of countless ammonites littered the seafloor in a breathtaking display of diversity. This ocean was not destined to last. The immense tectonic forces that fractured Pangaea sent the continental plates on a slow, unstoppable collision course. Africa and India, once part of Gondwana, drifted relentlessly northward, closing the Tethys like a pair of colossal doors. The ocean floor had nowhere to go. As the continents met, the ancient seabed, with all its accumulated sediments and fossils, was caught in the middle. It was forced upwards, crumpling and folding in a monumental act of creation. The very bottom of the Tethys Ocean became the top of the world. Its sediments now form the towering peaks of the Alps, the Himalayas, and the Zagros Mountains. Today, climbers on Mount Everest can find fossilized seashells, a silent and stunning testament to a lost marine world. The legacy of the Tethys is a profound reminder that even the mightiest oceans can vanish, leaving behind only mountains as their tombstones, a theme we will see echoed time and again in Earth's restless history. Even the mightiest oceans can be reborn as mountains, yet other transformations are more cyclical, a slow pulse of life and death written not in rock but in climate. The Sahara Desert, a vast and seemingly eternal ocean of sand, holds the ghost of one such cycle. Beneath its dunes lies the memory of a green paradise. Just 5,000 years ago, a blink of an eye in geological time, this was not a desert at all. It was a verdant savannah, a landscape so lush we call it the Green Sahara. This was the African humid period, a time when rivers snaked across the plains and vast lakes shimmered under the sun, their shorelines bustling with life that seems unthinkable there today. The evidence for this lost world is etched in stone. On the remote Tassili Ennaja Plateau in Algeria, ancient rock art panels tell a silent, stunning story. These are not the images of a desert people. They show herds of elephants, towering giraffes, and even humans swimming among hippos and crocodiles, scenes that depict a land of plenty, a world utterly alien to the hyper-arid emptiness of the present. What force could possibly orchestrate such a dramatic reversal? The answer lies not in the land itself, but in the sky. A slight wobble in Earth's orbit, a regular celestial rhythm, gradually intensified the African monsoon. For millennia, this shift pulled vast moisture-laden winds deep into the heart of the continent, turning what is now the world's largest hot desert into a sprawling grassland. This was not a unique event, but part of a recurring cycle that has painted the Sahara green many times over the past several 100,000 years. Modern technology has confirmed what the ancient artists recorded. Satellite radar can peer beneath the sand, revealing the skeletons of immense river systems and the buried shorelines of megalakes. The fossilized pollen found in lakebed sediments tells a botanical story of grasses and shrubs, not dunes. This cyclical greening and drying is a powerful testament to the fragility of our planet's ecosystems. It shows us that environments we perceive as permanent are often just a phase in a much longer, more dynamic story. The Sahara's past asks us a haunting question. If a climate shift could turn a thriving savanna into a desert in just centuries, what does that tell us about the stability of our own world? That same celestial rhythm that greened the Sahara also locked away immense volumes of water in colossal ice sheets, pulling the oceans back to expose a continent that does not appear on any modern map. The Bering Land Bridge was not a mere strip of land, but a vast, cold, and windswept subcontinent nearly 1,000 miles wide, a place we call Beringia. This was the Mammoth Steppe, a dry grassland ecosystem that thrived in the cold, supporting an incredible array of giant creatures. Herds of woolly mammoths, their long tusks curving against a stark sky, shared this land with steppe bison and the formidable scimitar cat. This was a world built for giants, a thriving, frigid paradise connecting two worlds. For thousands of years, this land bridge served as a bustling corridor, not just for these magnificent animals, but for something far more momentous. Following the trails of these great beasts, the first human populations made their way from Asia into the Americas, walking across a landscape that is now entirely lost beneath the waves. This migration was one of the most pivotal journeys in human history, all made possible by a world that would soon vanish. As the last ice age waned, the great glaciers began to melt, and the oceans, like a slow, inexorable tide, began to reclaim what they had lost. The seas rose foot by foot, century by century, slowly drowning the Mammoth Steppe. The Bering Strait we see today, a frigid channel of water separating Alaska from Russia, is all that remains of this once great continent. The submerged plains of Beringia now lie silent on the seafloor, a drowned world holding the archaeological clues to humanity's great dispersal. Its disappearance severed the land connection between the hemispheres, isolating the peoples of the Americas and setting the stage for thousands of years of independent development, a profound separation of worlds that would echo through history until just a few centuries ago. The ground did not just shift, it cracked open on a continental scale. While forces above ground were reshaping coastlines and climates, a far more violent drama was unfolding from the planet's interior. In what is now India, the crust tore itself apart in a series of volcanic paroxysms so immense they are almost beyond comprehension. This was the birth of the Deccan Traps, a landscape forged in pure chaos. For thousands of years, lava did not simply erupt from discrete volcanoes. It flooded from gigantic fissures in the earth, a relentless tide of liquid rock that engulfed the land. These floods of basalt built up one upon another, creating a geological formation thousands of feet thick that eventually covered an area nearly half the size of modern India. The name itself, traps, comes from the Swedish word for stairs, a perfect description of the stepped hills and plateaus that remain today, the weathered ruins of that primordial inferno. But the true impact of this event was felt far beyond the immediate region. The eruptions were a planetary-scale assault on the atmosphere. They pumped staggering quantities of volcanic gases into the sky, including vast clouds of sulfur dioxide that reflected sunlight back into space, plunging the globe into a volcanic winter. This was followed by a suffocating blanket of carbon dioxide, which then trapped heat and caused severe global warming. This 1-2 punch of climatic extremes would have shattered ecosystems worldwide, acidifying the oceans and collapsing food chains. The timing of this catastrophe is chillingly precise. It occurred 66 million years ago, the very moment the fossil record shows the end of the age of dinosaurs. While a massive asteroid impact at Chicxulub certainly delivered the final blow, many scientists now believe the Deccan Traps had already pushed life to the brink. The world's most powerful creatures were likely fighting for survival in a deteriorating world long before the asteroid darkened the sky. The legacy of the Deccan Traps is a humbling lesson in planetary power. It reveals that the greatest agents of change are not always from outer space, but can roar up from the world's own molten heart, capable of resetting the clock of life itself. While the Earth's crust was tearing itself apart in India, the North American continent was being flooded from within. For millions of years, a warm, shallow ocean split the landmass in two, creating a world where you could sail from the Arctic to the Gulf of Mexico across the continent's very heart. This was the Western Interior Seaway, a marine highway that completely reshaped the map of the ancient world. On its muddy, shifting floor, an incredible drama of life and death played out. The waters teemed with giants, enormous mosasaurs, true sea monsters that were essentially swimming Komodo dragons the length of a school bus, ruled these seas. They hunted alongside the elegant, long-necked plesiosaurs, while flocks of pterosaurs, some with wingspans rivaling small airplanes, soared overhead, snatching fish from the water. This seaway was not just a body of water, it was a biological barrier of immense power. It created two completely separate island continents, Laramide in the west and Appalachia in the east. Because these landmasses were isolated from each other, their dinosaurs evolved in wildly different directions. The iconic creatures we know so well, like Tyrannosaurus rex and Triceratops, were unique to Laramide, the western land. Meanwhile, on the eastern continent of Appalachia, a different and still largely mysterious cast of dinosaurs roamed, their fossils now mostly lost to erosion and the dense forests of the modern East Coast. This entire marine world was made possible by an Earth in a hot, high sea level state, where the ocean simply spilled over the low-lying interior of the continent. Its eventual disappearance was driven by a double blow. As the Cretaceous period drew to a close, global sea levels began to fall, and the land itself began to rise. The slow, monumental uplift of the young Rocky Mountains pushed the seafloor upwards, draining the Great Seaway back into the world's oceans. Today, the legacy of this lost American ocean is written in the very soil of the Great Plains. The vast, flat farmlands from Kansas to Alberta are the hardened, compacted sediments of that ancient seafloor. Every fossil pulled from the badlands of the Dakotas or the hills of Alberta, from the coiled shells of ammonites to the immense vertebrae of mosasaurs, is a relic from a time when the heartland of a continent was not land at all, but a sea of monsters. The world's greatest mountains can rise from vanished oceans, but the most profound disappearances involve entire continents. We have been taught since childhood that there are 7 continents, a neat and tidy number that fits perfectly on a classroom globe. Yet that number is wrong. There is an 8th continent, and you have almost certainly seen its highest peaks, even as 94% of its landmass lies hidden beneath the waves of the Pacific Ocean. This is Zealandia, a continent in its own right, a vast, submerged world that began to tear itself away from the supercontinent Gondwana around 85 million years ago. For millions of years, it was a full-fledged part of that ancient southern land, a place where dinosaurs roamed through lush forests. But then, its crust began to stretch and thin, like a piece of taffy being pulled apart. The continent grew weaker, and the ocean, relentless and heavy, began to claim it. The land slowly sank until all that remained above the surface were a few scattered mountaintops. These are the islands we know today as New Zealand and New Caledonia, not isolated islands in the vast ocean, but the highest alpine summits of a drowned continent. The evidence for Zealandia's continental status is etched into the very rock beneath the sea. Its crust is not the dense, heavy basalt of the ocean floor, but the lighter, buoyant granite that defines all other continents. It meets every single geological criterion to be called a continent, a fact that was only formally recognized in the last decade. Fossil discoveries on the islands provide glimpses of the world that was lost. The bones of unique dinosaurs and the imprints of ancient leaves tell us that this was once a thriving, green landscape, a world of terrestrial life that was utterly transformed. The story of Zealandia forces us to rethink a fundamental question. What truly makes a continent? Is it the land we see, or the geological reality hidden below? This lost world, hiding in plain sight beneath the Pacific, suggests that our planet's history is still being written, and its maps are far from complete. A continent can vanish beneath the waves, but sometimes the sea itself retreats from the land. The world's greatest rainforest, the Amazon, holds the ghost of a saltwater past. Long before it became a sprawling labyrinth of freshwater rivers, the entire Amazon basin was a giant, shallow inland sea. This was not a fleeting event, but a persistent marine world that existed for millions of years during the Miocene epoch, when the Andes Mountains were still low hills. At that time, this vast aquatic environment stretched for thousands of kilometers, openly connected to the Caribbean and teeming with life that seems impossible there now. The evidence lies buried in the soil. Paleontologists have unearthed the fossils of giant crocodilians, sharks, and manatee-like mammals in the heart of the modern rainforest, thousands of kilometers from the nearest ocean coast. These are not the remains of creatures that swam up a river, but of animals that lived and died in a genuine sea. This lost marine paradise was completely transformed by one of the most powerful geological events on the planet. The slow, relentless uplift of the Andes Mountains acted like a colossal plug, rising higher and higher until they finally blocked the Pacific Ocean's moisture and severed the basin's connection to the Caribbean. Trapped and with no outlet to the sea, the saltwater gradually turned to freshwater, creating a vast, island-dotted megalake. Over more millions of years, this great lake slowly drained, carving the intricate network of rivers that define the Amazon today. This incredible transformation from a salty sea to a freshwater system, and finally to a terrestrial jungle, holds the key to the region's mind-boggling biodiversity. The Amazon is a biological melting pot, a place where species that originally evolved in marine environments had to adapt first to freshwater and then to life on land. This layered history, written in stone and in DNA, created an explosion of life forms, a richness that echoes its complex, watery origins. The story of the Amazon shows that a rainforest can grow from the bed of a vanished sea, a testament to the planet's endless capacity for reinvention. These lost savannas were not empty stages but vibrant, living worlds. Across North America, a grassland teeming with giants stretched from coast to coast, a spectacle that would dwarf the modern Serengeti. Herds of woolly mammoths and mastodons, their footsteps shaking the ground, were stalked by saber-toothed cats with astonishingly long upper teeth, perfectly adapted for a single, devastating bite. Towering over this landscape was the giant ground sloth, a creature as large as an elephant, capable of standing on its hind legs to strip leaves from the high branches. Packs of dire wolves, heavier and more powerful than any wolf alive today, hunted the young and the weak. This was a world built on a scale we can scarcely comprehend. But this lost America was not unique. In South America, an equally bizarre and wonderful ecosystem thrived, dominated by the Glyptodon, a Volkswagen Beetle-sized armadillo covered in a bony, armored shell. Meanwhile, in Australia, the rules of life seemed completely different. That continent was ruled by marsupials, but on a colossal scale. The Diprotodon was a wombat the size of a rhinoceros, while Thylacoleo, the so-called marsupial lion, was a powerful, tree-climbing predator with uniquely shaped teeth that worked like bolt cutters. What force could possibly create such a global gallery of giants? The Earth itself was the chief architect. The planet was locked in an ice age, and the global climate was significantly cooler and drier. The atmosphere contained much less carbon dioxide, a condition that gave a tremendous advantage to hardy grasses over dense forests. This created a perfect environment for massive grazers to evolve, which in turn supported an entire ecosystem of specialized predators. So, what happened to this world of giants? The answer remains one of paleontology's most heated debates. The Great Ice Age was waning, and the climate was shifting rapidly, putting stress on these expansive grasslands. But at virtually the same time, a new and clever predator arrived on the scene, crossing the Bering Land Bridge into the Americas and sailing to the shores of Australia. Modern humans, with their advanced hunting techniques and coordinated groups, encountered these animals that had never learned to fear them. Was it the changing climate that fragmented their habitats, or was it overhunting by humans that delivered the final blow? The truth likely lies in a devastating combination of both. The disappearance of these great creatures was not just a loss of individual species, it was the collapse of an entire world order. Without mammoths and giant sloths to trample seedlings and prune trees, forests began to encroach on the open grasslands. The very pattern of wildfires changed as there were fewer large animals to consume the fuel that fed the flames. The landscapes we see today, from the North American woodlands to the Australian outback, are quieter, emptier versions of their former selves. They are ecosystems still reeling from a loss that occurred just 10,000 years ago, a ghostly echo of a world ruled by giants. The closing of the Tethys Ocean did not just build mountains, it also left a colossal, landlocked sea utterly stranded. Sealed off from the world's oceans by the rising Alps and Carpathian Mountains, the Paratethys Sea became a vast inland evolutionary laboratory. For millions of years, this was the largest lake in Earth's history. a body of water so immense it stretched from the northern foothills of the Alps all the way to the stark deserts of Central Asia. Cut off from global currents, its waters developed their own unique chemistry and rhythm, fostering a menagerie of creatures found nowhere else on the planet. In this isolated world, the rules of evolution were rewritten. Large marine mammals with no vast oceans to roam became smaller. The Paratethys was home to dwarf whales, creatures no bigger than a modern dolphin, and miniature seals that navigated its brackish shores. The most bizarre residents might have been the giant swan-sized geese that patrolled its coastlines, a testament to the strange possibilities of an isolated ecosystem. Yet this unique world was incredibly fragile. The Paratethys was at the mercy of the climate, and as global temperatures shifted, it underwent violent cycles of expansion and contraction. During dry periods, the sea would shrink dramatically, its waters evaporating and becoming intensely salty, a toxic brine that would trigger mass extinctions, wiping out the unique species that had evolved there. When the rains returned, the sea would refill, only for new, isolated species to evolve once more, starting the cycle again. Today, the ghost of this great sea lingers in three famous and troubled bodies of water. The Black Sea, the Caspian Sea, and the nearly vanished Aral Sea are all that remain. They are the last shrunken fragments of that lost world, and they still hold living relics of its strange past, like the Caspian seal, a species whose ancestors were trapped there millions of years ago. The story of the Paratethys is a powerful lesson in how isolation creates uniqueness, and how that very uniqueness becomes a vulnerability when the world outside begins to change. Far from the familiar peaks of the modern Rockies, a much older and more peculiar mountain range once dominated the American West. The Laramide Orogeny did not create a continuous wall of mountains, but instead thrust up a series of colossal, isolated blocks of rock, like a giant had scattered massive stone mesas across the continent. This mountain-building event was a geological mystery, occurring hundreds of miles inland from the usual tectonic collisions at the continent's edge. The result was a landscape of profound and dramatic vertical relief, a world of towering highlands standing beside deep, sediment-choked basins. These high-altitude forests and sheltered valleys created a complex mosaic of ecosystems, a patchwork of isolated worlds where evolution could experiment. Within the quiet mud of those deep basins, a spectacular fossil record was preserved, capturing the dawn of entirely new lineages. It was here, in the shadows of these forgotten peaks, that some of the earliest known primates scurried through the trees, and the first horses, no larger than a house cat, began their evolutionary journey. The very shape of the land, with its intricate drainage patterns and rain shadows, dictated where life could thrive, yet the forces that built these mighty highlands eventually waned. The immense tectonic pressure relaxed, and the relentless work of erosion began. Wind, water, and ice slowly but surely started to grind these great blocks down, filling the basins with their own rubble over millions of years. This long period of destruction was essential, clearing the stage for the younger, more familiar Rocky Mountains to form through a later, different uplift. The ghost of that ancient, rugged world is still with us, its worn-down roots forming the very foundation of the iconic American West, a reminder that even the mightiest landscapes are merely temporary sculptures in stone. Even the most stable-seeming seas are not immune to utter catastrophe. The Mediterranean, a cradle of civilization, holds evidence of its own near-total destruction. Around 6 million years ago, the tectonic dance of Africa and Europe squeezed shut the vital connection at the Strait of Gibraltar. The Mediterranean Sea was suddenly cut off from the lifeblood of the Atlantic Ocean, transforming from a thriving marine passage into a doomed, landlocked lake. With only rivers to feed it and the hot, dry sun beating down upon it, it began to die. The basin started to evaporate faster than any rainfall or river could replenish. The waters receded mile by mile, century by century, leaving behind a horrifying new landscape. The floor of the Mediterranean became a hellscape of salt. As the water vanished, it precipitated out immense quantities of dissolved minerals, building up layers of salt and gypsum over a kilometer thick in some places. This was the Messinian salinity crisis, a period where one of the world's great seas turned into a vast, scorching desert of salt flats, a bitter white plain under a relentless sky. The rivers that once gently met the coast were now confronted with a terrifying drop. The Nile, the Rhone, and other great waterways responded by carving down, slicing canyons thousands of feet deep into the continental shelf in a desperate race to reach the plummeting water level. These ancient buried gorges, now filled with sediment, still lie beneath the modern river deltas, hidden scars from this apocalyptic drought. The crisis was not a local event. So much water was locked away in the evaporated Mediterranean that global sea levels dropped significantly, while the salt content of the rest of the world's oceans rose, putting immense stress on marine life everywhere. For over 500,000 years, this was the new, brutal reality. Then the end came with breathtaking speed. The Atlantic Ocean, held back by a natural dam at Gibraltar, finally overtopped it. What began as a trickle became a roar, then a world-changing flood. The Atlantic burst through in a catastrophic deluge, carving a deep channel and pouring into the empty basin below. It was a waterfall 1,000 times more powerful than Niagara, a titanic cascade that roared non-stop for years, possibly even decades. The sound alone would have been a continuous planetary-scale thunder. The Mediterranean basin, which had taken centuries to dry out, was refilled in a geological instant. This violent rebirth permanently reshaped the region's coastlines, drowned the incredible canyon systems, and completely reset the biology of the sea. Any unique life that had adapted to the hypersaline lakes died in the sudden return of normal ocean water. Today, the evidence of this forgotten desert lies buried beneath the blue waves. Seismic surveys reveal that thick layer of salt, a stark, ghostly tombstone for a time when the Mediterranean Sea simply vanished from the face of the earth. The blue expanse of the North Sea hides a sunken homeland. Beneath its cold, churning waves lie the drowned hills and valleys of Doggerland, a vast plain that just 12,000 years ago connected Britain to mainland Europe. This was no barren land bridge, but a lush and habitable world in its own right, a heartland for Mesolithic hunter-gatherers who tracked herds of reindeer and the formidable wild aurochs through its forests and marshes. They fished in its winding rivers and hunted across its rolling hills, living in a landscape so rich and stable it supported a significant human population for millennia. Their world was slowly, inexorably shrinking. As the great ice sheets melted at the end of the last ice age, the oceans rose, a relentless, creeping flood that measured inches per year but feet per century. Over thousands of years, the rising seas transformed this continental plain into a shrinking coastline, then a fragmented archipelago of low-lying islands, pushing the human inhabitants steadily westward toward the higher ground that would become Britain. The end did not come with a slow submersion alone. Around 6,200 BC, a catastrophic event far to the north delivered the final blow. A massive section of the Norwegian continental shelf, known as the Storegga Slide, collapsed into the deep sea. This underwater landslide, thousands of cubic kilometers in volume, displaced an enormous wall of water, sending a devastating tsunami racing across the North Sea. For the last communities clinging to the remnants of Doggerland, This would have been an unimaginable catastrophe, a towering wave scouring their already diminished islands and sealing the fate of their world forever. Today, the only reminders of this lost European heartland are hauled up from the seafloor by fishermen. Their nets occasionally bring up not just fish, but the dark peat of ancient forests, the bones of long-extinct mammoths, and carefully worked flint tools, silent and poignant evidence of a human world that now lies silent beneath the waves. For millions of years, the American continents were strangers, living separate lives divided by a deep ocean passage. The Panamanian Seaway was not a narrow strait but a broad marine highway where the Pacific and Atlantic mingled freely, their waters creating a global climate system vastly different from our own. This open channel allowed powerful equatorial currents to flow westwards, distributing the sun's heat evenly across the planet and maintaining a warm, stable world with far less extreme temperature differences between the poles and the equator. But this equilibrium was doomed. The relentless march of tectonic plates, pushing the Pacific floor against the stubborn edge of South America, began to crumple the Earth. Volcanoes burst forth from the sea, their fiery eruptions building new land, while the collision of crustal fragments slowly, painstakingly, began to stitch a bridge. This was not a sudden event, but a geological project that took over 12 million years to complete. The final closure of the Isthmus of Panama was a switch thrown on the planet's climate machine. With a throughway blocked, the equatorial current was deflected. It had nowhere to go but north, giving birth to the mighty Gulf Stream as we know it today. This new, warm river in the ocean began pumping vast amounts of heat and moisture directly towards the Arctic, a delivery system that paradoxically fueled the very ice ages it seemed to defy. How could a warm current cause an ice age? The increased evaporation in the North Atlantic fell as immense quantities of snow, piling up year after year into the colossal ice sheets that would grind their way across North America and Europe. The planet's climate, once so uniform, was now a system of stark contrasts. Yet on land, a very different kind of exchange was beginning. With the sea barrier gone, a land bridge stood open for the first time in over 100 million years. The Great American Biotic Interchange was a grand, chaotic experiment in migration. Armored glyptodonts and smaller armadillos plodded north from South America, while saber-toothed cats, towering mammoths, and early llamas charged south. This was not a peaceful meeting, but a biological revolution. The long, isolated ecosystems of South America, which had fostered bizarre and unique marsupial predators, were suddenly confronted with more competitive placental mammals from the north. The results were catastrophic for many native southern species, which were outcompeted and driven to extinction. This single geological connection, born of fire and tectonic force, did more than just connect two land masses. It rerouted the oceans, iced over the north, and forced a dramatic reshuffling of life across half the world. A cascade of consequences from one narrow strip of land that reminds us how interconnected our planet's systems truly are. The land bridge at Panama rerouted the currents of the world, but long before that tectonic shift, the planet was already locked in a state of extreme heat. For millions of years during the Cretaceous period, Earth was a true hothouse, a world without a single speck of permanent ice at its poles. The planet's thermostat was cranked to a setting we would find almost alien today. This was not a world of frozen wastelands at its extremes, but one of lush, green forests thriving in constant twilight. Dinosaur bones and the fossilized stumps of great trees are found today in the bitter cold of Alaska and Antarctica, lands that were once verdant, temperate woodlands. These polar forests were home to a unique caste of dinosaurs, creatures that evolved to cope with months of perpetual darkness in the winter and endless daylight in the summer. They were not merely surviving, but thriving in an environment that would be completely inhospitable to most large animals now. What could possibly power such a global furnace? The engine was the very air itself. Intense and prolonged volcanic activity, like the Deccan Traps we discussed earlier, pumped staggering amounts of carbon dioxide into the atmosphere, creating a supercharged greenhouse effect. This trapped the sun's heat so effectively that the temperature difference between the equator and the poles was remarkably mild, allowing for a comfortable, even climate across the entire globe. This warmth had a direct and visible effect on the world's geography. With no ice caps to lock away water, the sea levels were vastly higher than they are today. Shallow, warm oceans sprawled across the continental interiors, like the Western Interior Seaway that split North America. These epicontinental seas acted like giant solar panels, absorbing heat and releasing moisture that fueled a planet-wide tropical weather system, creating a stable and storm-free environment for life to flourish. This stable, warm, and resource-rich world became the stage for the most spectacular giants our planet has ever known. It was in this hothouse that the titanic sauropods reached their greatest sizes, their long necks sweeping the canopies of polar forests, while the oceans were patrolled by leviathans like the monstrous Mosasaurus. The sheer abundance of plant life, supercharged by the high carbon dioxide levels, supported an almost unimaginable food chain. The Cretaceous Hot House proves that our planet's default setting is not the icehouse world we know today, but something far more volatile and lush. It represents a radically different equilibrium, one that shows us the astonishing range of climates Earth is capable of sustaining when its atmospheric chemistry is profoundly altered. Southeast Asia's iconic islands were once the highlands of a sunken world. During the last ice age, the deep waters that now separate Sumatra, Java, and Borneo from the mainland simply did not exist. With the oceans locked away in colossal ice sheets, a vast continental shelf lay exposed to the air, creating a sprawling subcontinent scientists call Sundaland. This was a single, unified landmass larger than India, a low-lying plain of dense rainforests and immense, winding river systems that stretched all the way to the edge of the continental slope. The islands we recognize on a modern map were merely the mountainous interior of this lost world, their peaks serving as highland refuges in an otherwise flat and humid landscape. This connected geography made Sundal and one of the most critical superhighways for life on the planet. Early human populations, having traveled from Africa, moved steadily across this fertile plain, following the trails of animals and the courses of great rivers. Their journey did not stop at the coastlines we see today, but continued eastward across the dry land, all the way to the edge of the shelf, where they could look out upon a new challenge, the open ocean separating them from Australia and New Guinea. This land bridge was the essential corridor that allowed humanity to populate the far reaches of Southeast Asia and ultimately make that first, daring ocean crossing. But this entire world was living on borrowed time. As the Ice Age waned, the meltwater had to go somewhere. The seas began a relentless rise, not as a single, catastrophic wave, but as a creeping, unstoppable flood that advanced for generations. Coastlines that had been stable for thousands of years were suddenly on the move, swallowing forests and river valleys under tens of meters of salty water. For the people living there, it would have been a slow-motion disaster, a visible, tangible loss of their homeland that unfolded over centuries. Vast stretches of hunting grounds and ancestral forests were permanently drowned, forcing communities into a constant retreat toward the higher ground of the mountainous islands. This profound, collective memory of a lost land beneath the waves is thought by many scholars to be the seed of the great flood myths that are so prevalent across Southeast Asian cultures. The legacy of Sundaland, however, is not only written in myth. It is alive in the incredible biodiversity of the region. The rich ecosystems of Borneo and Sumatra are not just products of their current isolation, but are the shattered fragments of a much larger, connected ecosystem. The unique species found on these islands, from the orangutan to the Sumatran tiger, are the living heirs of that vast subcontinental refuge. Their ancestors roamed a continuous world, and their current isolation is a direct result of the seas returning to claim a forgotten landscape, dividing a single, thriving kingdom of life into the scattered islands we know today. The fossils embedded in the limestone of southwestern France tell a warm, watery secret. This region, known as Aquitaine, was once the heart of a tropical seaway, a Miocene-era paradise where coral reefs thrived in water warm enough for a modern-day Bahamas. For millions of years, a shallow sea covered the land, its clear, sunlit waters nurturing a vibrant ecosystem that seems unthinkable there now. The proof is in the stone. Quarries and cliffs reveal the intricate structures of fossilized coral, the massive, ribbed shells of giant clams, and the sharp, unmistakable teeth of sharks that once patrolled these vanished waters. This was not a barren sea, but a bustling marine metropolis, a European Caribbean teeming with life. The very existence of these reefs reveals a planet out of balance, a world where the heat of the tropics reached far into what are now temperate latitudes. Europe was a continent without a winter, its climate so uniformly warm that coral polyps could build their limestone cities with ease. This paradise, however, had an expiration date written in the global climate. A slow, planetary cooling was already underway, a descent into the ice ages that would grip the world. As the global thermostat dialed down, the ocean currents shifted and the sea temperatures began to fall, degree by critical degree. For the coral, this was a death sentence. They are exquisitely sensitive organisms, and the cooling waters became a creeping poison, starving them of the warmth they needed to survive. The bustling reef systems gradually fell silent, the corals dying off and the tropical fish dispersing or going extinct. The sea itself eventually retreated, leaving the skeletons of the reef to be buried and fossilized, a spectacular graveyard of a lost climate. You can now walk through the quiet, sun-drenched hills of the French countryside and stand on the remnants of a coral atoll, a powerful and tangible reminder that the world we know is not the world that has to be. The line between a tropical coast and a temperate one is not fixed in stone, but written in the fragile language of global temperature, a lesson etched into the very bedrock of France. High in the thin air of the Andes, the world's largest mirror reflects a vanished age. The Salar de Uyuni, a stark white plain of salt stretching to infinity, was once the bottom of a colossal inland sea. This entire region, the Altiplano, is a plateau so vast and high it seems to touch the sky, a place where the very scale of the landscape defies belief. Yet 16,000 years ago, this austere realm was a world of deep, blue water, a system of giant, interconnected lakes, the greatest of which was Lake Tauca, flooded the high plains. This was not a small collection of ponds, but a freshwater ocean perched above 12,000 feet, deeper than 400 feet, and larger than Lake Michigan. Its waters were a stunning, impossible blue against the harsh brown of the surrounding peaks, a vibrant aquatic heart in the roof of the world. Those ancient shorelines are still there today, etched like bathtub rings on the distant mountainsides, a permanent watermark from a wetter time. This lost water world was a crucial refuge. Its rich fisheries and fertile shores supported unique ecosystems and provided a lifeline for the earliest human cultures to brave these punishing altitudes, their survival inextricably linked to the lake's abundance. Then the rains faltered. A profound shift in the global climate pushed the region into a long, dry phase. The Great Lake, with no river to drain it, had only one fate. The sun and wind began their work, pulling trillions of gallons of water into the atmosphere. As the lake shrank, its waters grew increasingly salty, concentrating the minerals that had washed down from the surrounding volcanoes over millennia. The fish vanished, the shorelines receded, and the great inland sea slowly boiled away. What remained was a mineral ghost. The salts precipitated out of the evaporating water, layer upon layer, creating the vast, flat crust we see today. The modern Lake Titicaca is a tiny, freshwater remnant of that age, a last living puddle from the Great Torcan Sea. The Sala de Uyuni is its spectacular tomb, a brilliant, blinding monument to the power of a changing sky. To stand on that salt flat is to stand on the floor of a forgotten ocean, a reminder that even the grandest bodies of water are fleeting gifts from the climate, here one geological moment and gone the next. The search for lost worlds often leads us down paths of pure imagination. Long before the discovery of Zealandia, another vanished continent was proposed, a land of pure speculation born from a genuine scientific puzzle. In the 19th century, biologists were baffled. How could the fossils of lemurs, those small, tree-dwelling primates, be found in both Madagascar and India, with no trace of them in between? The solution, proposed by scientists of the day, was a lost continent they named Lemuria, a vast land bridge that had supposedly sunk beneath the waves of the Indian Ocean. This was not just a fanciful tale, it was a serious, if flawed, scientific hypothesis to explain the mysterious distribution of life. Lemuria was envisioned as a tropical paradise, a sunken world that served as a biological highway for these animals, a story that captured the public mind with the same power as the legend of Atlantis. But science, like the Earth itself, is always shifting. The theory of plate tectonics provided the real and far more dramatic answer. Madagascar and India were not connected by a land bridge. They were once joined together as part of the supercontinent Gondwana. The lemurs did not cross a sunken continent. They were passengers on a raft of stone. As Gondwana broke apart, the Indian subcontinent, with its population of lemurs, slowly drifted away from Madagascar on a journey north that would last millions of years. That monumental rupture was accompanied by the same Deccan Traps volcanic events that scarred the planet, a force of destruction so immense it makes the quiet sinking of a continent seem almost peaceful. The hypothesis of Lemuria was ultimately discarded, replaced by the elegant, evidence-based model of continental drift. Yet its legacy endures not in textbooks of geology, but in the realms of mythology, esoteric philosophy, and popular fiction. It stands as a powerful cultural artifact, a beautiful wrong turn in the history of science. The story of Lemuria reminds us that our quest to understand the planet's past is a self-correcting journey, one where even our most appealing mistakes can inspire the search for deeper, more complex truths. The immense weight of the Laurentide ice sheet did more than just grind the continent down. Its southern edge was a place of constant, dramatic creation and destruction, a landscape defined not by solid ice but by colossal, trapped water. Pressed against the retreating glacier was a chain of proglacial lakes, trapped between a wall of ice to the north and the higher ground to the south. The greatest of these was Lake Agassiz, a body of freshwater so vast it makes our modern Great Lakes seem like a series of modest ponds. At its peak, this lake was a true inland sea, larger than all 5 Great Lakes combined, a shimmering, cold expanse that dominated the heart of the continent for thousands of years. But this was no peaceful, stable lake. It was a volatile giant held in check only by temporary ice dams. When these dams failed, the results were catastrophic. The lake would unleash its pent-up water in apocalyptic outburst floods, events of almost unimaginable power. These torrents of icy meltwater scoured the land with terrifying force, carving out entire river valleys in a matter of weeks. The Minnesota River Valley, for instance, is not an ancient feature, but a scar left by one of these colossal discharges, a channel gouged out by a wall of water from the dying Lake Agassiz. The impact of these floods was not merely local. The sudden, massive infusion of cold, fresh water into the North Atlantic Ocean may have been enough to destabilize the global conveyor belt of ocean currents. This critical system, which distributes heat around the planet, relies on a delicate balance of temperature and salinity. The fresh water from Lake Agassiz acted like a lid, preventing the normal sinking of cold, salty water that drives the entire circulation. The result was likely a period of abrupt and severe global cooling, a cold snap triggered by a melting ice sheet thousands of miles away. Eventually, as the ice retreated for the final time, Lake Agassiz found a permanent outlet and slowly drained away. Its disappearance left behind a completely new landscape, a gift of incredible fertility. The flat, featureless lakebed, covered in thick layers of fine silt and clay deposited over millennia, became the foundation for one of the world's most productive agricultural regions. The rich, black soil of the Red River Valley and the sprawling Canadian prairies is the direct legacy of this vanished glacial sea. We are still farming the bottom of Lake Agassiz, reaping the bounty from a temporary world of water that existed for a mere geological moment. This ephemeral lake demonstrates that ice ages are not just periods of frozen stasis, but eras of profound and rapid transformation, where the meltwater of retreating glaciers can rewrite the very map of a continent and reshape its future. Even the most barren landscapes are haunted by the ghosts of water. Beneath the towering, rust-colored dunes of the Namib Desert, one of the oldest and most arid places on our planet, lies the skeleton of a lost world. This is not a desert that briefly turned green, but one that has cycled through wet and dry phases for tens of millions of years, and the evidence of its lush past is buried just below the surface. Advanced satellite imagery and ground-penetrating radar have peeled back the layers of sand to reveal a stunning secret, a sprawling network of ancient river channels carved deep into the bedrock. These are not small, seasonal streams, but colossal paleochannels, some even larger than the modern Orange River, the greatest waterway in southern Africa. They once formed a mighty arterial system, carrying life-giving water from the distant African interior all the way to the cold shores of the Atlantic Ocean. Where endless sand seas now ripple under a relentless sun, there were once flowing rivers flanked by savannas and woodlands, a vibrant corridor of life in a place we now consider a synonym for emptiness. This lost green world was very real, and it was inhabited. Archaeological discoveries along the courses of these phantom rivers tell a compelling story. Stone tools and the remnants of ancient hearths are found in places that are now utterly waterless, marking the campsites of early humans who hunted and gathered along these fertile banks. The fossil record adds another layer to the narrative, revealing the bones of animals that could never survive here today, creatures that required steady sources of water and abundant vegetation. This was a landscape that supported communities, both human and animal, for countless generations. So what happened to this African paradise? The climate pendulum swung back, as it has done many times before. A gradual shift in global weather patterns starved the region of its rain, and the rivers began to wither. Without the constant flow of water to maintain them, the channels slowly choked with sediment and were then systematically buried by the very sand the wind now scoured across the land. All that remains of these mighty rivers today are their skeletal outlines, filled not with water but with compacted gravel and hard calcrete deposits, a ghostly network preserved in stone beneath the desert. The lesson of the Namib is written in this subterranean script. It shows us that the most extreme environments on Earth are not permanent, but are simply one phase in a long, cyclical drama of climate change. The hyper-arid emptiness we see is a mask, and beneath it lies the clear, enduring memory of a greener, wetter world, a testament to the planet's endless capacity for reinvention and a quiet promise that even the driest places hold the deep time story of life itself. A forgotten continent has been hiding in one of the world's most familiar tourist destinations. Recent discoveries have revealed that long before the sun-drenched islands of Greece and Turkey dotted the Aegean Sea, this entire region was a single, cohesive landmass known as Balkanatolia. For 10 million years, from about 50 to 40 million years ago, this was an isolated world, a lost continent in its own right that bridged the Balkans with Anatolia. Cut off from the major continents by seaways, Balkanatolia became an evolutionary laboratory, a refuge for a menagerie of creatures found nowhere else on Earth. Its fossil record tells a story of profound isolation. Here, bizarre and specialized mammals roamed freely, embrithopods hefty, rhinoceros-like herbivores with peculiar skulls and teeth, grazed the landscape alongside unexpected residents like marsupials, whose presence in this part of the world was a complete surprise to scientists. This was a unique kingdom of life, a biological arc floating between Europe and Asia, yet completely distinct from both. Its peaceful isolation, however, was doomed. A double catastrophe sealed its fate. Global sea levels began to rise, and the relentless motion of tectonic plates caused the land itself to sink. The great, unified continent of Balkanatolia was slowly drowned, its heartland fragmented into the scattered archipelago we recognize today. As the land bridges between the new islands vanished beneath the waves, a new land connection was forming elsewhere, linking Balkanatolia directly to Asia. This was the final blow. With the gates now open, a wave of new, competitive mammals from Asia swept into this fragmented world. The native animals of Balkanatolia, which had evolved for millions of years in peaceful seclusion, were completely unprepared for these invaders. They were rapidly outcompeted and driven to extinction. The disappearance of this lost world solves a long-standing mystery in paleontology. For decades, scientists were puzzled by a sudden and dramatic turnover in European mammal fossils around 34 million years ago. The story of Balkanatolia provides the missing context, revealing that this was not a local European event, but the final echo of a continental collapse. An entire evolutionary arena, a stage for unique life, was simply erased from the map, its history submerged until modern researchers pieced together the clues from sunken shorelines and forgotten fossils. The Sahara holds the ghost of a freshwater sea. Deep within the Chad Basin, a body of water once existed on a scale that defies the very concept of a desert. This was Mega Lake Chad, a colossal inland ocean that just 7,000 years ago expanded to cover an area larger than the modern Caspian Sea. Its waters stretched over 150,000 square miles, a shimmering blue expanse in the heart of the driest region on Earth. This was no temporary pond, but a thriving, pulsating heart of life. The lake supported a vibrant ecosystem, its waters teeming with fish, while hippos and crocodiles basked on its lush green shores. This aquatic paradise was also a human one. Countless archaeological sites dot the ancient shoreline, revealing the tools and settlements of Neolithic communities. These were not nomadic desert dwellers, but fishermen and pastoralists who built their lives around the abundance of the megalake, a way of life completely dependent on its vast, life-giving waters. This world, however, was living on borrowed time. The same climatic rhythms that once greened the entire Sahara began to falter. A long, slow aridification set in, and the rains that fed the Great Lake grew sparse and unreliable. The megalake began a relentless retreat, shrinking century by century, its shorelines receding like a slow, unstoppable tide. What remained was the much smaller, struggling Lake Chad we see today, and something else entirely, a vast, flat plain of dried sediment known as the Bedele Depression. This is not just any patch of desert. The lake bed, now a fine, mineral-rich powder, is the single largest source of dust on our entire planet. Powerful winds, known as the harmattan, sweep across the depression, lifting billions of tons of this ancient lakebed into the atmosphere each year. This dust then embarks on an incredible transcontinental journey, caught in air currents that carry it all the way across the Atlantic Ocean. When this Saharan dust finally falls, it does not land on barren ground. It settles over the Amazon rainforest, delivering vital nutrients like phosphorus that are desperately scarce in the ancient, weathered soils of the jungle. The Amazon's breathtaking fertility is in part sustained by the corpse of a forgotten African lake. The fate of mega Lake Chad is a stunning demonstration of interconnection. A local environmental collapse, the drying of a single basin, did not just create a desert, it triggered a planetary-scale recycling system. A change in one corner of the globe now directly nourishes life in another, proving that even a vanished landscape can reach across an ocean to shape the world we know today. Our planet's memory reaches back to a time before animals, before plants, before even a complex cell existed. The supercontinent Rodinia was the world's first great continental assembly, a colossal landmass that came together over 1.3 billion years ago. This was a world of profound silence, a vast and empty interior of barren rock under a strange young sun, its coastlines lashed by the waves of a single global ocean. The very configuration of this primordial continent is a fierce debate among geologists, its map constantly redrawn as new evidence emerges from ancient, weathered stone. What is not debated is the sheer, raw power of its demise. Around 750 million years ago, Rodinia began to rip itself apart at its seams. As the continent fractured, it exposed vast stretches of fresh, dark rock to the atmosphere. This newly bared basalt acted like a colossal sponge, chemically pulling carbon dioxide, the planet's main greenhouse gas, out of the air. With its atmospheric blanket thinning, Earth's thermostat plummeted. The ice began at the poles, but it did not stop there. It spread, a creeping white death, until it is possible the entire planet, from the equator to the poles, was encased in a layer of ice over a mile thick. This was Snowball Earth, a global, deep freeze apocalypse triggered by the death throes of a forgotten continent. Yet within this catastrophe, a seed was planted. The very forces that shattered Rodinia also created a network of warm, shallow seas along the newly formed continental margins, bathed in mineral-rich runoff from the eroding land. These sheltered environments became crucibles of change, safe havens where the simplest single-celled life could experiment with new forms. The breakup of Rodinia did not just shatter a continent, it broke the long, static stalemate of early life. The stage was now set, cleared by ice and fertilized by rock, for biology's greatest spectacle. The tectonic drama of this ancient world, a saga written in fire and ice, was the necessary prelude to the riot of life that would one day burst forth in the Cambrian explosion. Rodinia's legacy is the ground beneath our feet and the very fact of our existence, a reminder that the most barren of worlds can hold the promise of everything to come. The Sahara holds one last, almost unbelievable secret, a paradox written in stone. Long before it was a desert, and even before it was a green savannah, this land was a frozen wilderness carved by ice. Deep in the Algerian Sahara, the bedrock tells a silent, startling story. Scratched across the surfaces of ancient sandstone are glacial striations, long, parallel grooves cut by the relentless grind of a massive ice sheet. These are not the marks of a passing sandstorm, but the permanent signature of a continent-sized glacier that once smothered this very spot. This ice was part of a global winter that descended over 440 million years ago during the Ordovician period, when the supercontinent Gondwana had drifted directly over the South Pole. The Sahara was not a sea of sand, but a polar ice cap. As this colossal sheet of ice advanced and retreated, it behaved exactly like the glaciers that sculpt modern Norway. It gouged deep, U-shaped valleys into the continent's heart. When the climate eventually warmed and the ice melted, the world's oceans, now free of their frozen prisons, rose to claim this scarred land. They flooded those freshly carved valleys, transforming them into a network of dramatic fjords. Imagine a coastline of deep, blue inlets cutting into a stark, rocky shore. A landscape that would look perfectly at home in Alaska today, yet it existed where the world's largest hot desert now lies. The evidence does not stop with the scratch marks. The sedimentary deposits left behind, known as tillites, are the compressed and hardened rubble that was pushed along and dropped by the ice, a chaotic mix of boulders, sand, and clay that could only be formed by a glacier. Finding this material in the middle of the Sahara is as disorienting as finding a palm tree in Antarctica. This lost world of Saharan fjords is a humbling lesson in planetary motion. It proves that the ground beneath our feet is on a slow, constant journey, and that the climate of any place is not a permanent identity, but a temporary visitor. The poles themselves are wanderers over geological time, and the Sahara's frozen past forces us to ask a final, profound question about our own future. If the planet's climatic zones can be so utterly rearranged, what other forgotten landscapes might be waiting, not in the deep past, but in the centuries to come? These vanished worlds are not a random collection of curiosities, but pieces of a single grand puzzle. They are all bound by a few powerful, unifying threads that weave through the entire history of our planet. The first and most fundamental is the relentless, slow-motion dance of tectonic plates. This is the engine that builds and destroys continents, the force that raised the Himalayas from the bed of the Tethys Ocean and tore Zealandia away from Gondwana, only to drown it. The ground beneath us is not a fixed stage, but a raft of stone adrift on a sea of molten rock, and its journeys over millions of years have redrawn the world map time and again. The second thread is the powerful, often cyclical, influence of climate change. This is not a modern phenomenon, but a planetary constant. A slight wobble in Earth's orbit greened the Sahara and later baked it dry, while the shifting of ocean currents, triggered by the rise of Panama, plunged the planet into an ice age. The planet's climate has always been a pendulum, swinging between hothouses and iceboxes, and these shifts have repeatedly made and unmade entire ecosystems. The third, and perhaps most poignant, thread is the dynamic interplay between life and its environment. The Great American Biotic Interchange shows how a new land bridge can trigger a biological revolution, while the fate of the mammoth steppe reveals how the arrival of a single species, humanity, can collaborate with a changing climate to topple a world of giants. Each of these 25 lost landscapes, from the frozen Sahara to the sunken realm of Doggerland, was shaped by these global-scale processes, forces that are just as active today as they were millions of years ago. This is why these forgotten worlds are more than just fascinating history. They are the key to understanding our own future. The same mechanisms that drained the Western Interior Seaway are still pushing continents apart. The same climatic rhythms that filled and emptied Lake Torca continue to govern the monsoons. By studying these past environments, we gain the perspective needed to anticipate and adapt to the changes that lie ahead. They teach us a profound humility, forcing us to recognize that the world we consider permanent, with its familiar coastlines and stable climates, is merely a snapshot in deep time, a single frame in a movie of constant, dramatic transformation. Our planet is not a museum, but a vibrant, ever-evolving system, and its past landscapes are the clearest guide we have to the world that is yet to come. Our journey through these 25 lost worlds reveals a planet in a state of constant, dramatic flux. The ground we stand on is not a fixed stage but a temporary arrangement, a fleeting snapshot in a 4.5 billion year long story of creation and destruction. We have walked across the supercontinent of Pangaea and sailed the inland sea that split North America. We have witnessed a green Sahara and a frozen one, understanding that the climate of any place is merely a visitor, not a permanent resident. These narratives are far more than geological curiosities. They are the foundational code to our modern world, the deep history that explains why our continents are shaped the way they are, why certain animals live where they do, and how the very air we breathe came to be. The same tectonic forces that raised the Himalayas from the Tethys Ocean are still pushing the Americas away from Europe and Africa. The same climatic rhythms that filled and emptied mega Lake Chad continue to govern the rains that feed billions today. By studying these forgotten landscapes, we gain the perspective needed to see our own time not as an end point, but as a single chapter in an epic that is still being written. The Earth's story is one of relentless transformation, and its past is the clearest guide we have to the future that is yet to come. If these vanished worlds have captivated your imagination, the journey does not have to end here. Subscribe for more explorations into the deep past, and let us know in the comments which of these forgotten landscapes you found most fascinating. Was it the sunken continent of Zealandia, the mammoth steppe of Beringia, or the Saharan fjords carved by ice? The conversation about our planet's incredible history is just beginning.